Hi, everyone. Nice to meet you. Thanks, Paolo, for the introduction and VDPH for all of this. It's great. It's a great bunch of people and a great venue. Yes, so we've been talking about this concept. Me and Paolo, we've been talking about this for years. At the beginning, just as almost a joke, and then we decided to make it a more theoretical experiment, I would say. And today, my contribution will be mostly about the idea of depth. As Paolo said, the Megadungeon and dungeons in general, something that I imagine to go deep into the earth or into space. And I want to think about what does depth means in digital contexts. So that's why my presentation will be a bit speculative into the idea of volume and volumetric media. And this image is actually the end of Minecraft. So if you walk inside Minecraft for a very long time, eventually you get to this invisible wall. Then the player cannot go, but the space continues to exist and being generated, randomly generated after it. So my presentation is grounded into this theoretical shift in anthropology and geography that's been called a volumetric turn. So a turn towards not just surface and topography, but volume and volumetry. It's been more than 10 years that this shift has been begun to be theorized, but the main idea is that when you think through volumes, it's not just about topography and adding a vertical dimension. It's more about thinking about actual volumetric spaces and intersections. And there is a couple of great collections of articles about the volumetric turn. And in one of them, they make this point that the subterranean realm, which we often assume to be static, is just Earth all the way down, is actually a space of continual rolling and churning, blurring boundaries between types of matter. So I thought that's a good theoretical ground for thinking about the Megadungeon. And what interests me is the contrast between surface and depth, because in cultural studies, and for example, in Frederick Jameson, he theorizes about postmodernity as a time when a certain kind of flatness emerges in culture. So with globalization and postmodernism, culture becomes flat. There is no depth. He says a kind of superficiality that is the formal feature of postmodernism. And this has been also extended to digital humanities and literature. This is a book from last year called Flat World Fiction. It's mostly about American literature. And the author recognizes this common thread in contemporary American literature, where digital media and computation are imagined to flatten society. So our relationships become flat, the screens are flat, the social world becomes flatter. And even more recently this year, there was an article that connects the flatness of smartphone screens and digital screens. You know, flat screens are great, right? We always want the flattest screen and the thinnest screen. He connects, this is Andrew Wright, he connects this flatness with the so-called flat ontologies that are more and more popular in philosophy and science and technology studies. The work of Bruno Latour and all people after him. So the flat ontology would be an ontology that's different from the more Kantian tradition, where the humans and objects are all in a network and they're all peripheral to each other and there is nothing at the center and it's all imagined to be this flat network. So there is this ongoing idea that the digital and computation flattens things. And I want to argue the opposite. I want to argue that there has always been an idea of depth that is important in digital media, starting from the entire idea of three-dimensionality, of putting depth into the digital, into video games and rendering. In this book, Image Objects, there is a very good archaeology of depth. because how depth is created into 3D renderings is through calculations of what is called a depth map. So you need to map depth. This is against the topographical idea of mapping a surface. You map the depth. And these depth maps and depth in digital renderings are a way to achieve perfect realism and total simulation. So the idea is that depth brings realism, depth brings reality and totality of simulation. And of course, there is more and more attention to depth in virtual reality. You want to achieve a good depth of field. There are articles about how virtual reality gave people a better depth perception. New virtual reality headsets will let you focus at any depth and so on. So depth is very important in virtual and augmented reality, obviously. For example, this is a demo of Google's augmented reality APIs, where they say depth adds realism. And as an app developer, when you do augmented reality, you want to blend the virtual and the real. And how you do this is through depth. So you want the algorithms to recognize the real world with its depth and integrate renderings in it that look more realistic, right? And of course, the final metaphor of depth is deep learning. So a lot of things in artificial intelligence and machine learning, one of the most recent advancements that a lot of things are built on is deep learning, which is deep metaphorically in the sense that in deep learning, data passes through different layers of machine learning. And this allows the machine learning system to become smarter or better at doing certain things like recognizing faces. So a machine learning system does not recognize a face. It starts from a very simple feature, and then by passing through different layers, it's able to recognize more and more complex things. So this is why depth, I think, is a very important element in digital culture. But also, this has been true from early on, as Paolo said. So it's not just a matter of expertise and theory, but depth has been a key component of how we imagine digital media. So from very early multi-user dungeons that Paolo introduced, that were kind of the forerunners of video gaming. And some digital humanities scholars have mapped the multi-user dungeons and actually discover that when you map them three-dimensionally, you obtain structures that are very similar to actual dungeons or underground catacombs or mines, right? This is a visualization of a digital a video game, text-based video game, basically, by Peter Anders, that looks like sort of that three-dimensional underworld. More mapping of virtual communities like Alpha World have developed this idea of stacked levels that allows you to see things at different scales. So these communities are not only layered, but also you can zoom in and zoom out quite easily. And I can give you an example from the very popular video game called Dwarf Fortress, which is a contemporary sort of dungeon roguelike, which is all procedurally generated. And what you see in the base version is this map made of letters. I don't know if you can see, but they're all made with the ASCII characters. And what's impressive is that this game, Dwarf Fortress, this is the entire world. And the scale is quite amazing because you can zoom in almost forever and see more and more detailed features from regions to cities, and then zoom in into a single castle, and then inside a castle you have your dwarfs living their life. And there's been academic analysis of Dwarf Fortress that evidence how this surface world with different resources and social activities has a very real world topology, but the wealth of the game, the ones you want to get, the gems, the gold, the resources are underground. So you need to dig into different layers of digital representations, which are also procedurally generated. And of course, maybe one game that you're more familiar with is Minecraft, which is exactly the same logic. So it's a world made of blocks, and you can just dig deeper and deeper for kilometers, literally creating this dungeon-like passages. And eventually you can find the ultimate boundary at kilometers underground. And also there is a lot of popular imaginations of the internet as something that is deep. This is one, you know, those funny images you find online where there is the cloud and the web that we all surf on the surface. And then you have the deep web with the government and conspiracy theories and illegal porn. And similar memes about also conspiracy theories also play on this idea of a layered depth. So there's, you know, the famous iceberg meme in which the things at the top everybody knows, and then the more you go into the bottom layers, the more obscure and weird things happen. So there is a sort of a vernacular fantasies of depth that are connected to digital media. So people imagine this media through depth. And more recently, this famous sort of horror story about the back rooms also plays on this idea of you get stuck outside of reality and you end in this maze-like structure that looks like an abandoned American hotel that's all yellow walls and carpets, and there is a lot of weird haunting noises around. And Samantha Culp has recently written a beautiful article about this, this myth of the backrooms, which she calls, or she thinks it's connected to more ancient traditions of uncanny geography, such as the Minotaur's labyrinth or Piranesi's imaginary prisons and all these speculative spaces. So people tend to imagine the speculative, weird spaces to make sense of contemporary life. As Paolo has hinted, this then shifts to the technical domain. So of course, engineers and informaticians imagine the internet and digital media through these layered models, ranging from the physical to the very much software stuff. This is a very famous model that everybody uses to think through the internet, is the OSI model. And then this is being recuperated by media theorists like Benjamin Bratton by conceptualizing a stacked model in which platforms and computation are at the center. And these layers are both independent and interdependent. So things, whatever you do when you go online passes through different layers, through different paths that are different every time and almost follow the same logics as those video games we were talking about. They are algorithmically, procedurally generated and responsive to conditions. And more recently, there has been a lot of work on this idea of the stack across disciplines. I just mentioned a couple. Genevieve Costello has written about this idea of userscapes. So each individual interaction with the stack, so with whatever media you use and infrastructures you use, creates new paths or cuts out different parts of the stack, and then or volumetric regions that you occupy with every interaction. And she calls these userscapes. And in my own work, I theorized about 3 different configurations of the stack that I called gateways, sieves, and domes. So different ways in which data and users flow through the stack, through these passages or through filters, or they are overlapped by geopolitical and other kinds of surface areas. And I want to conclude by giving you a few examples of why I think depth and volume are important for any kind of analysis across disciplines. So volumetric epistemologies. So what can volume and depth contribute to knowledge? How do we know about volume and depth? And one very immediate way is the idea of a point cloud. Today, these are very popular forms of mediation, right? So a point cloud is a very simple thing. It's a cloud of digital data points that are used to represent physical spaces. You can get this kind of visualization through scanning. These are actually some promotional materials from a Chinese drone manufacturer and that uses LiDAR to scan the space around you. But these point clouds are widely used today, from self-driving cars to 3D scanning and modeling and all kinds of applications. But more recently, there have been advances in artificial intelligence that allow you to create a 3D object like this one you see here by simply starting from some photographs. So the photos that you see on the top left of the screen, they're just normal photographs of this crane from different angles. And all you need to do is to input a few images into a machine learning system called NERF that you can then get as an output a very detailed cloud of data points that to us, to the human eye, looks like a 3D model. But this is not a video. This is not an actual 3D model. This has been procedurally generated through photographs. So the algorithm, this algorithm learns and imagines depth out of photographs, which is quite impressive. It's going to change a lot of media practices, I think. And even more practically, one example from a Finnish colleague of mine called Aleksi Nutila. This is an ongoing work in progress that's called This Inequality Does Not Exist. And what you see here are images of London, but they're not actual places in London. These are generated by a machine learning system trained on 15,000 images of London streets from Google. Intersected with a data set of social economic data like salaries and income deprivation, education, and environmental harm. So he used the intersection between these two kinds of data, visual and economic, to generate what London looks in an abstract sense in a higher or lower education context, or in high income or low income context. And so you can literally see the image change. And for example, the homes getting taller or lower, and the cars getting more or less expensive, but you're not seeing any actual place. This is simply a way to navigate data points in a way that is interpretable for humans. So I think this is a way in which you can look into the depth of data without getting lost, or make it interpretable to humans. And finally, an even more interesting example is this project by Olli Bohan, in which he used a similar approach to train a machine learning system on a Pokemon game, a video game. So first thing, he fed the system a lot of stills from the game, and then the system learned to generate new ones that look realistic. But then he combined them with depth, and the depth is given by the controls of the game. So forward, left, right, and back. And what happened is that the system learned to generate new images in response to movement. And so what happened is that you can play the game by making the machine dream what would happen next. And so you can create a sort of video game that is completely procedurally generated, and there is no software no game engine that runs it. It's all an imagination of what will happen next. And I think this is a beautiful metaphor for what a data-based Megadungeon would look like, what it would look like to literally walk inside a data set. And I will actually show you, because I can play it live. So now you can see a very standard video game screen. That's my character, but this is all, there is no game behind it. This is just artificial intelligence dreaming the most likely video game area. And as soon as I move, it will blur and it will regenerate different things, trying to figure out what would happen next. So as you can see, He's struggling because everything's black, and then he's creating a new scene. And this has never existed in the game. These are just purely quantitative approximations of what the game should look like, but I can literally move left and right and explore this space that's always different every time you play. And it's almost like, yes, it's, I think, one of the rawest examples of walking through a large data and experiencing computation happening around you. And I think it's quite fascinating to see how every step changes the landscape and recreates a new shades. There are shapes that morph, and you never know what's happening next. So I think this is a good example of what something like the Megadungeon can contribute to understanding digital media. This idea of walking through a shifting data landscape that's always procedurally generated. So I'm going to finish my talk with some conclusions. I would like to contribute, so my contribution today would be some thoughts on the idea of digital depth. So the first conclusion is that digital and the digital media and the digital are not flat, despite a lot of imagination about flatness. And it is worth following the volumetric turn in human geography and anthropology into different kinds of digital depth. And the most obvious ones are 3D modeling, virtual reality, augmented reality, deep learning, in which depth is thought of as a better simulation, more realism, and the emergence of intelligence, perhaps. But also, I want to emphasize that there have been undercurrents of depth from the beginning of digital media, multi-user dungeons, video games, all those imaginaries, up to today's virtual worlds like Minecraft or Roblox. And all of these shape how people, the vernacular imagination of digital space. People always imagine the digital through some kind of depth. Theories of the stack or stack models help us conceptualize computation through this layering and through depth. But I also think that digital depth demands new ways of what I call volumetric knowing. So how do we know about this sort of digital depth that's not just a physical three-dimensionality? So we need to think about objects like point clouds, synthetic media, or even what are called latent spaces of computation. Thank you.